Hi students, so I got a couple of things I want to show you today. First of all, a great study tool. Okay, so I went to gemini.google.com. I went to like Google's little AI thing. I'm logged in with my free account and I typed in this question. I said create 5 questions about quantum numbers for a general chemistry undergraduate course. All right, and not only did it create 5 questions for me, it put them in this like little quiz format and it's got hints involved. So this is a really great study tool that I hope you'll take advantage of. All right, and then the other thing that I'm going to do in this video is I'm going to go over some quantum number questions. I do want to mention that I have not screened these. I have not clicked that next button, so we're just going to see what happens. I'm going to give you a brief review about quantum numbers. Okay, so I'm using my snipping tool so I can write on my screen, but that's the same question that is up there. Brief review about quantum numbers. Now, quantum numbers are describing where within an atom that an electron is located, and each individual electron has to have a different set of the 4 quantum numbers. Okay, so you've got within the atom, first of all, you've got the energy level. Okay, that's the N value. So the N quantum number is the energy level. Okay, that N quantum number, first of all, allowed values for it are from 1 up, but they need to be whole numbers. So allowed values are N has got to be greater than 0. Okay, and it's going to be whole numbers like N equals 1, N equals 2. Those are the energy levels that can be found within the electron. Now within those energy levels, we have sublevels. That's where our L quantum number comes in. These are your sublevels. Okay. Now you may have studied sublevels already, and you know that the normal sublevels that we talk about are S, P, D, and F. Those are our sublevels within the atom. Now those sublevels, their L values are 0, 1, 2, and 3. So S has a 0, P has a 1, D has a 2, and F has a 3. All right, so with your L values, your allowed values for L go from N up to, go from 0 up to N minus 1. Okay, so up from 0 up to N minus 1. All right, so then within those sublevels, we have orbitals. So that's where this M sub L comes from. This is where we're actually getting down to the sublevel. All right, now your allowed values for your orbitals go from negative L up to positive L. Okay, so those are our allowed values. Okay, just to kind of make a little some connections here. Okay, we know that the number of orbitals within the different sublevels are 1, 3, 5, and 7. Okay, so for example, let's say you have a D sublevel. Okay, so the D sublevel, D is equal to 2. L is equal to 2 because it's a D sublevel. And then the allowed values for M sub L go from negative 2, negative 1, 0, 1, and 2. We followed this rule right here. The allowed values for M sub L go from negative L up to positive L. So these are the allowed values for M sub L if you're in an L equals 2 sublevel. So what does that actually mean? These are the names of the orbitals. We've just named that there's 5 potential orbitals in a D sublevel. One of them's the negative 2, one of them's the negative 1. These are like assigning names to those orbitals. Okay, and then last of all, you have the M sub S. This is where you've actually gotten down to the electron, and each orbital can hold up to 2 electrons. So the allowed value of M sub S are positive 1/2 and negative 1/2. Okay, so that's a brief introduction to quantum numbers. We're going to apply that to these questions that have been asked up here. All right, so for this first one, it says, what are the possible values for the angular momentum quantum number, which is L, when the principal quantum number is equal to 4? All right, so if N is equal to 4, the allowed values for L are from 0 up to N minus 1. So 0, 1, 2, and 3. We had to stop at n minus 1. So my answer for that one is going to be 0, 1, 2, and 3, which is A. Let me jump back over here. We're going to click A. Hey, that's right. Yay. Okay, and then we're going to hit next and find out what our next question is. Okay, an electron occupies an orbital for which the angular momentum quantum number is L is 2. Which type of subshell is this found in? Well, I have that on my little review over here. If L is equal to 2, you're in a D subshell. Okay, so like S, P, D, and F is 0, 1, 2, and 3. All right, we're in a D subshell. Okay, good job. All right, moving on to the next one. Okay, what is this thing blinking at me for? I have no idea. Okay, we're just going to keep moving. How many distinct orbitals are possible within a subshell defined by the angular momentum quantum number L equal to 3? Okay, that's on my little overview also. If L is equal to 3, you're in an F sublevel, which means you can have up to 7. You're going to have 7 orbitals. Okay, so S, P, D, and F has 1, 3, 5, and 7 orbitals. You want to see a fun fact? Have you ever seen how you can get that off of the periodic table? Let me grab, this is my little website. Here's just a periodic table that's color-coded by the sublevels. Like this is my S, this is my P, this is my D, this is my F. The F block down at the bottom of the periodic table, if you count that across, there's 14 of them. Okay, 14 of them. Well, that's done very intentionally to indicate to us that those atoms can potentially have 14 electrons in that F block. Okay, so 14, as you count across, you get 14. Divide that by 2, and that gives you the number of orbitals that that sublevel can hold. All right, so I forgot my answer here. L equals 3. L equals 3 is a, and see, I don't have this stuff memorized. I have these systems in my mind. I know the systems. I don't necessarily memorize, but that's I'm teaching you guys the systems. So if L equals to 3, that is an F sublevel. That is 7 orbitals. Okay, so 7. Hey, that's right. Good job. Okay. And then number 4 here, it says, which of the following sets of quantum numbers is not permissible for an electron in an atom? So it's asking us which one obeys the rules. All right, so this first one is my n value. All right, so if n is equal to 3, then the allowed values of L go from 0 up to n minus 1. So 0, 1, and 2. That's fine. We have not violated a rule. All right, and then it says if L is equal to 2, the allowed values of M sub L go from negative L up to positive L. Got to get my little screen here. So if L is equal to if L is equal to 2, my allowed values of M sub L are negative 2, negative 1, 0, 1, and 2. Okay, this one's allowed. That's good. And then these guys out here on the end are always just going to be either positive 1/2 or negative 1/2. This one is permissible. That one, they have followed the rules. Let's look at this one. N is equal to 2. My allowed values of L are 0 and 1. That's allowed. If L is equal to 1, then my allowed values of M sub L are negative 1, 0, positive 1. That's allowed. This one's good. All right, this one I see an issue with, but let's talk about it. If my N is equal to 3, okay, then my allowed values of L go up to n minus 1. So my allowed values of L are 0, 1, and 2. This one has a problem. Okay, you have violated the allowed values of L. And guys, everything's based off of the number directly to its left. Okay, so this one's going to be limited by whatever this one was. Okay, so just to mention this one, if n is equal to 4, allowed values were 0, 1, 2, and 3 for L. If this is 0, then M sub L must be 0, and then that one is positive 1/2. Okay, all right, we got one more question. Let's check it out. Okay, what does the electron spin quantum number M sub S primarily represent in the description of the electron? It is really getting down to the actual electron. It's not the energy level, that's the n value. It's not the orientation of the orbital in space. This is going to be the actual electron, the intrinsic angular momentum of an electron, which is quantized by one of 2 possible values. I like how they're saying there's only 2 possible values. The other thing that positive 1/2 and negative 1/2, what you really have going on there is a spin. Okay, so that positive 1/2 is describing the spin of one electron. And just a little fun fact, we know from physics that there's a lot of overlap between charged particles and magnetism, right? So if you have a charged particle that is moving, that's creating a magnetic field. Well, not everything's magnetic, right? And so having another charged particle moving the opposite direction does away with the magnetic field. It cancels it out. And so that's why we need one electron moving this way with a positive direction and the other electron moving this way with a negative direction. So that's why it's positive 1/2, negative 1/2. C is our answer. Okay, we have done very well in our little review here. It has given us 100, and we've also discovered that Gemini is a great way to create little quizzes for yourself when you're getting ready for your whatever test you're doing. Okay, have a great day.